here at the Week 0 event with Team 4909 Billerica Robotics. They're going to walk us through their arm and their intake along with some of their code. Coming up next on Behind the Bumpers.
This video on fun is brought to you by viewers like you and also in partnership with the following. AndyMark is your one-stop shop for all your robotics competition needs. Celebrating 20 years of quality robotics parts and superior service, AndyMark employees have over 200 years of first-team experience. From mechanical and electrical products to tools and hardware, head on over to andymark.com for high-quality and affordable solutions. Support Fun's content creators when you sign up for a membership on YouTube Join. You'll get access to special perks like emotes, loyalty badges, and Fun members will even get early access to our scheduled videos and more. 100% of this revenue will go back to our correspondents to help recognize their efforts. Click the Join button in any YouTube video to pledge your support.
Okay, so the intake here is an under the bumper intake. It basically is run by two different sets of rollers that take in the game piece. Our main issue with this was the packaging. We had a really small amount of space, so we had to make it super duper tight. And then our second issue was centering. So we kind of took inspiration from some open alliance teams, and we kind of did a sort of Wyndham centering mechanism with a wheel in the center. So that way, on this side. So when the game piece goes in, the wheel will take it and it will bring it up, and along with some grippy tape to make sure it stays there as it passes through the system.
Cool, so after it passes through the system, it's handed to the arm. So can you tell us a little bit more about the arm?
Yeah, so the arm is a double jointed arm, and what's neat about it is that it's cantilevered, so there's place for the shooter to pass through. And this is cantilevered, but it's okay because the entire shaft is precision ground and it's held by tension. So this is a very strong, rigid member of the arm. And we run it through two Falcons down here, and it all passes power up all the way up to the shooter. So we're able to move it independently, and it makes it easier for software control if it's able to pass through.
Cool, so tell us a little bit more about the shooter.
So for our shooter this year, we kept it relatively simple compared to our other subsystems. So we have two sets of wheels. We have two feeder wheels that are both powered off of one Falcon that's down here. So we have one gear. This runs to a one-to-one gears that reverse the direction, so the rollers spin in the opposite directions. We felt like we didn't need two Falcons because we did a lot of testing and we felt that it was adequate. So that takes the note from the intake, and once we're ready to shoot, we have two flywheels that are each powered by an individual Falcon, and they are belted one-to-one, which leads our note to leave our shooter at about 35 miles an hour, which is an absolute laser beam. We've gotten it stuck in the roof a couple times. So we're really happy with our shooter this year.
So it looks like you have a lot of subsystems that work really well together. How did you design with other subsystems in mind?
Yeah, so one of the main things we wanted to focus on this year was being able to do the subsystem integration part. And because of that, we did a whole bunch of revisions. So back there, you can see that's our Rev 2. We call it Cobra because it's all black. And you can see it's a little bit more janky. It's we're using wood as hard stops. And this is our Rev 2. We actually had another Rev 1, which didn't even have an arm. It just had the shooter and the intake. And that's how we were able to kind of perfect getting the pass through and getting the arm on and stuff like that. So the subsystems you see on there are the third revision of the robot. And that's how we're able to kind of make sure everything works right.
Very cool. So with that and all the complexities, I'm sure that you guys have a lot of programming that goes into this robot. So can you tell us a little bit more about the code?
Yeah, so a lot of our processes are automated. So the intake to the arm, all that is automated. And when we go to the source, all that is on a single button press. So what's cool about this arm is because of the way it was designed, it acts more like two single jointed arms in software, which makes the dynamics a lot easier to control for. And we've been experimenting with motion magic and different types of motion profiles to get the best control. And it's been working really good. It's a really good system. And we also have two cameras on the back. And we're using these for vision localization so we can get our pose. And this will be used later in the season when we get into things like auto aiming and shooting on the move, which we hope to do.
Can you show us more about your TPE wheels that you use?
So we use SLS printed TJ wheels. These are designed by Team 88 TJ Squared. And they're very good. We've seen very low wear with these wheels, and they've been working really well for us, and there's very little slip.
Very cool. Thank you, Team 4909. We'll see you out on the field, and good luck in your 2024 season.
This video on fun is brought to you by viewers like you and also in partnership with the following. AndyMark is your one-stop shop for all your robotics competition needs. Celebrating 20 years of quality robotics parts and superior service, AndyMark employees have over 200 years of first-team experience. From mechanical and electrical products to tools and hardware, head on over to andymark.com for high-quality and affordable solutions.